Quantum physics, often regarded as the realm of the subatomic and incomprehensible, might seem far removed from the everyday behaviors of animals. However, recent research has uncovered surprising links between quantum mechanics and how some animals navigate the world. It turns out that many creatures, ranging from birds and bats to marine life, seem to exploit the principles of quantum physics, such as superposition, entanglement, and tunneling, to solve complex problems of navigation that would otherwise be impossible. This astonishing discovery has opened up new fields of study, raising questions not only about how animals manage to do this, but also about the potential applications of quantum biology in understanding the mysteries of nature. One of the most widely known examples of quantum physics at play in the animal kingdom is the migration of birds. Birds like the European robin use the Earth's magnetic field as a navigational guide during their long migrations. The key to their ability to sense this magnetic field lies in a protein called cryptochrome, found in their eyes. This protein is sensitive to the magnetic fields around the Earth, but it doesn't simply function in a classical sense. Rather, it appears to work through a quantum process known as radical pair formation. When cryptochrome absorbs light, it triggers the formation of radical pairs, pairs of electrons with opposite spins. These electron pairs exist in a quantum superposition, meaning they can be in multiple states simultaneously. The interaction between these spins is influenced by the Earth's magnetic field, allowing the bird to detect the orientation and intensity of the magnetic field with remarkable precision. This process enables the birds to navigate across vast distances with an uncanny accuracy that classical physics alone cannot explain. Moreover, the phenomenon known as quantum entanglement plays a role in the way some animals sense their environment. Entanglement occurs when two particles become linked in such a way that the state of one particle immediately influences the state of the other, no matter how far apart they are. In the context of animal navigation, entanglement is thought to be involved in the way certain species of bats and birds use echolocation. Bats, for instance, emit high-frequency sound waves, which bounce off objects and return to them. By analyzing the time delay and frequency shift of the returning sound waves, they can create a mental map of their surroundings. What is fascinating is that recent studies suggest that quantum entanglement could enhance the precision of these echolocation processes, allowing bats to detect objects with a level of detail and sensitivity that classical physics would predict to be impossible. Another striking example of quantum mechanics in the animal kingdom is found in marine life, specifically in the case of certain species of fish and sea turtles. These animals also rely on Earth's magnetic field for navigation, but their ability to perceive and respond to magnetic fields appears to involve a quantum mechanism that is even more complex. In sea turtles, researchers have uncovered evidence suggesting that their magnetic compass is based on a quantum entanglement process involving the protein cryptochrome, similar to that in birds. However, in the case of sea turtles, this process is even more finely tuned, as they are able to detect not just the direction of the magnetic field, but also its intensity and inclination. This gives them an extraordinary ability to navigate over long distances, even across oceans, without relying on traditional landmarks or visual cues. Beyond birds, bats, and sea creatures, quantum mechanics has also been implicated in the behavior of some insects. One fascinating example is the monarch butterfly, which migrates thousands of miles from North America to central Mexico every year. Scientists have long been puzzled by how these tiny creatures manage to find their way, often navigating across unfamiliar landscapes. Recent studies suggest that monarch butterflies, like birds, may use quantum processes to perceive the Earth's magnetic field. In this case, the quantum mechanism involves the butterfly's ability to sense the polarization of light as it interacts with the magnetic field, helping them to determine both their position and direction. It's important to recognize that the role of quantum mechanics in animal navigation is still an emerging field of study. While many of these ideas have gained traction in recent years, there are still many unanswered questions. For instance, it remains unclear just how quantum effects, which typically operate at microscopic scales, can influence the behavior of whole organisms. Classical physics, after all, works perfectly well in explaining how large-scale systems function. Yet, as quantum biology demonstrates, nature has a way of transcending classical limits, allowing animals to tap into this strange and powerful realm of physics to gain extraordinary capabilities. Researchers are only beginning to scratch the surface of how these processes work, with many of the experiments still in their infancy. However, the potential implications are vast, opening up new avenues for technology and our understanding of the natural world. The study of quantum physics in animals also challenges our assumptions about consciousness and the brain. Traditional views of cognition and sensory perception have often relied on classical models of how information is processed. However, quantum mechanics introduces a new layer of complexity, suggesting that some animals may be able to process information in ways that were previously unimaginable. For instance, in the case of bird navigation, the brain might be able to process quantum information, specifically the state of the electron spins in cryptochrome proteins, to help the bird orient itself in space. This challenges our classical understanding of how the brain works and raises intriguing possibilities about the interaction between quantum mechanics and neural networks. These insights are not just academic, they have real-world applications as well. Understanding how animals use quantum physics to navigate could lead to breakthroughs in technology, especially in fields like quantum computing and navigation systems. Quantum sensors, inspired by the biological mechanisms of animals, could revolutionize how we measure magnetic fields or detect subtle changes in the environment. For instance, quantum-based sensors could improve navigation technologies for autonomous vehicles, submarines, and aircraft, offering a new level of accuracy and reliability. Additionally, the exploration of quantum biology could contribute to advancements in medical science, particularly in the realm of diagnostics and imaging, by taking advantage of the same principles animals use to interpret their surroundings. One of the most fascinating aspects of these quantum phenomena is the fact that they exist on the edge of classical physics and quantum mechanics. While classical physics governs the macroscopic world, the everyday objects we interact with, quantum mechanics operates in a realm where particles behave in ways that defy ordinary logic. Yet, through some as yet unknown mechanism, animals are able to bridge these two worlds, incorporating quantum principles into their biological processes. This raises profound questions not just about animal behavior, but also about the fundamental nature of life itself. How is it that living organisms, over millions of years of evolution, have developed the ability to tap into such an esoteric realm of physics? What does this tell us about the potential of life to interact with the quantum world? And how might this influence our understanding of consciousness, perception, and reality. In conclusion, animals' use of quantum physics to navigate the world is an extraordinary reminder of how much we still have to learn about the natural world. From birds and bats to sea turtles and butterflies, many species seem to have evolved the ability to utilize quantum mechanics in ways that challenge our conventional understanding of biology and physics. While much of this research is still in its infancy, the implications are profound, offering new insights into the mysteries of the natural world and the potential for groundbreaking technological advancements. As our understanding of quantum biology deepens, we may find that nature's ability to harness the laws of quantum mechanics is far more widespread and far more sophisticated than we could ever have imagined.